The first thing that you're going to notice when using the saw is that the base and the clamping system aren't really that great. They have some nice features like this quick adjustment system, but the rigidity of this setup here just isn't that great. You want to be sure that the blade is cutting on the down stroke. You see how the blade will rotate this way, and for this piece it's going to be cut only into the material like this on the down stroke. If you have stock that's really deep and you have to reposition the fence back further, they have a special clamp that you insert into grooves in the back that's pressed down against the material. If you do over tighten, the material will start lifting up off of the table and you won't have a square cut. You can also start to distort the fence and the vise. If you have large stock, you should support it the same height as the space. If you're cutting small slivers like this off, use a different type of saw. There's still quite a bit of space between the blade and the base, and these slivers can easily bound up. You need it to be able to cut 6-inch material, and you do have to move it back to the second position. There's marks on the base for helping you to find where 90 degrees is. Double check the fence with a square. You can get 6-inch pieces in here. 6-inch piece would be cut on that upstroke. Tighten it down and proceed. You need to have a substantial amount of material across it. If you have just a little bit like this, the vise is going to tilt. Even here, where I have material past that pivot point, how it's pressing onto this fence is going to cause that fence to rotate. So you want to have a decent amount of material against both the vise and the fence. There's a lot of material that gets caught down in this groove. There's really no access port. You get little burrs on plastic, or it tears sections of the plastic out. It's better to go slower. This one was done on a table saw. It's really smooth, but this has not very smooth. The nicest cut is probably this one here. You can see that really shiny aluminum, but this is what you more generally get, kind of this torn appearance. It's best to put the part like this that's being cut, because the fewest number of teeth are engaging. The surface finish really matters less than how square. I can see a little bit of light through that. The cut is square, the square is not rocking. Some pieces of 1215 steel, and I think these look really nice. This is a piece of 2-inch 1215 cold rolled steel. Just lightly press on it. If you see a lot of sparks coming off the blade, pressing too hard or the blade is terribly dull. Material cut by carbide has an interesting pattern, almost crystalline. This is a piece of 6061 aluminum. It's 1 1/4 by 3 inches. You can see the piece starting to vibrate. And I think this is occurring because the vise is not clamping the stock flat across the entire surface, but instead only at the very top. And this allows the stock to vibrate a bit at the bottom. With this saw I've cut 1215 and 1045 steels and 01 tools. They all cut well, I just went a little bit slower with the tool steel. A small amount of sparks when cutting steel is expected, but a large number of sparks could indicate that you're pressing too hard on the handle or that the saw blade is dull. The kilowatt meter can give us an idea of how much of the capacity of the saw that we are using. Thicker material, too fast of a feed rate, a dull blade, or harder material will all require more power. I backed off some on the feed rate, but didn't seem to have an effect on the production of sparks. The kilowatt meter shows that 1 amp less is being drawn than while cutting the 2.5-inch piece. And finally we'll check the squareness of the cut. It's pretty good, and it's probably as good as one's going to get with this vise and base. A bandsaw would do a little bit better, but this saw cuts much faster than a bandsaw.